So welcome to the NORR, and today it's the engineering series. We have Lloyd Keller with us, with two other guests, which I'll talk about in a few minutes. The format, as most of you know, is slightly changed. We have a guest speaker, and he'll be joined during the presentation. And today we have a guest from New York and one for Colombia, which should be an exciting session. So that's our session for today, and we're looking forward to the next one in December. Before I talk about the NORR, I wanted to talk about something that I've been involved in for most of this year, and that's the Italian Contemporary Film Festival, which was supposed to be in June of this year. And I thought I'd take this opportunity to talk to everyone about it. It's going to happen on the November the 29th through December the 8th. And it is going to be virtual, and it's going to be on Rogers on demand. So it is going to be in the safety of people's homes. You'll be able to watch the films in your home. I'm on the architectural board, and this year we actually have two films. One is the Renzo Piano film, L'Architetto della Luce, and the film will be introduced by myself. And before we watch the film, we are going to actually do a piece on the new Toronto courthouse. So there's been some filming that's been done on the new Toronto courthouse. So there'll be an introduction to the new Toronto courthouse if you watch that film. The second film will be a new film on Palladio, which is an excellent film, and it will be introduced by a former NORR architect from the 90s, Jamie Cooper, who is currently a professor at Penn State, who actually teaches Michelangelo, and he is going to do the introduction to the Palladio film. Those are the two architectural films. And the film festival is fairly interesting in that it's going to be delivered through on demand. So you'll be able to watch one film for $6.99, or you'll be able to buy a pass for $30, which will allow you to watch all 13 films whenever you want, which is a great way to see the festival in the comfort of your own home on your own screen. So I'm actually going to send out something to all of the NORR offices and a number of our guests on it, but you can definitely go online right now and just type in ICFF. It's live right now, and you can actually view all the films. They are Italian films, but they're all with subtitles, and they're excellent films. And if you're interested in Fellini, there are two Fellini films that are in the film festival. So I thought I'd share that with everyone that's online. It's an excellent way to watch more than the boring news that you watch on a daily basis in the comfort of your own home. So for today, we have Lloyd Keller, Elliston Corporation, Ryan Conley from Thomas Phifer and Partners out of New York, and Jermaine Hermida from Cemex in Colombia. That are with us today. So if you read the introduction, I joined NORR, and for everyone, certainly in the Toronto office, who's tired of me talking about Skydome, I will talk about Skydome again. I met Lloyd probably the first day on Skydome, and if you've watched any of my presentations on Skydome, I don't think there are too many buildings that have 210,000 tons of concrete in them. And Lloyd was just to be, just ordinary about it, the concrete guy, and I was the roof guy. And spent a lot of time together because my roof sat on his concrete, and I had to keep waiting until this concrete came up to the roof. And I learned a lot about concrete. And I think Lloyd learned a lot about concrete in the 3 years that we were building Sky Dome. And it was just an incredible building. The amount of research that both Lloyd did with concrete and the amount of research that I had to do with moving roofs, we learned an incredible amount. And I think that both our careers went in obviously different directions, but our careers, I would say, probably started with that building and the camaraderie. And I think that the amount of effort that went into working together on that project, I don't think that either one of us have ever forgotten that building. Today, Lloyd is in high demand on projects. I've run into Lloyd over the years, and he's at almost every conference that I can think of. He's probably one of the guys that certainly I refer to when we're talking about concrete, certainly with standards, buildings. We're working on the Toronto courthouse currently, and I made sure that we had Lloyd involved in the Toronto courthouse. We're not finished with the Toronto courthouse. That's still under construction. I thought it was really important that we have Lloyd on board this year to do this session. Lloyd is going to be talking in detail about the head office, and I'm not going to take anything away from his presentation, but the one building that he's going to be talking about, he's going to be talking about it in depth, and we've had 2 or 3 dry runs over the last couple of weeks with the other 2 that are going to be on this presentation, and I think that you're really going to enjoy what they have to say about the one building that they're going to be talking about. So Lloyd is the founder of Research and Development and Quality Control for Ellis Don Construction in Mississauga, Ontario. He's an American Concrete Institute Fellow and participates in numerous committees for ACI and CSA Group in Canada. He was educated in BCIT in Canada and specializing in civil and structural engineering technology. His research efforts has been over the last years focused on self-consolidation concrete ACI 237 and prediction of concrete formwork pressure, shotcrete for structural installations, and control of exonometric heat generation and utilization of high volume supplementary cementing materials is also an area of research over the last few years. As Scott Hunter and I don't know if Scott is on the line, when people get into trouble, I know at Ellis Don, Lloyd is the guy that they usually call upon, and he has a group of people that work for him. It's not just him. It's quite a resource to have in a company. Ryan Conley is joining us from Thomas Phifer and Partners in New York. He's an associate at Thomas Phifer. He's the project architect for Cine Columbia headquarters in Bogota, Colombia, and has been closely involved in many of the firm's architectural concrete projects. Prior to joining Thomas Phifer and Partners, he contributed in a wide variety of projects in New York, including large residential developments and adaptive reuse of landmark buildings. He has a Master of Architecture from Yale University and a Bachelor of Science in Architecture from Ohio State University. He's a registered architect in the state of Ohio. German Hermeda is the director of CIMEX Columbia Technical Department since 2014. He has a PhD from ENSEC, 2008 Paris, École Nationale des Ponts de Charmes. His research interests are concentrated in low cement paste concrete, concrete shrinkage, chemical admixtures, CCR waves analysis, and study of concrete properties. He's a professor in the Columbian Engineering University. He was a consultant for CCR and CFRD dams. So this is the incredible image of the Columbia head office building in Bogota, Colombia, which is the focus of the presentation that Lloyd, Keller, and our other two guests will concentrate on for the presentation. And with that, I'm going to turn this over to Lloyd Keller.
Great. Okay. Okay. So yeah, we were going to be talking about again the headquarters for Cine Columbia, which is a project in Bogota, Colombia. The outline that I wanted to talk about today, we've got, I think the first thing I want to mention is that this is by far a really interesting project. And one of the key things that we learned from this, and one of the important things, is that we worked on a communication protocol where all of the people were involved, from the project staff, from the owner, from the architect, from the construction manager, and ourselves, right from the beginning, prior to even letting out the subcontracts for all of the participants in the structure that we're going to be talking about. And that was a very vital part of the whole project. And so this communications and the coordination and the efforts is, I think, within about the first week that I got involved in this project, we had started on weekly coordination meetings, and these ran for a period of about a year and a half, 2 years, weekly, where we were very involved and everyone was engaged in the process. This is an outline of what I wanted to talk about. The first part is an investigation or installation review. Basically, it's utilizing reference installations to understand the desires of the architect and the owner, and also to be able to present the attributes to which we wanted to achieve, and also to show items that we didn't want to carry through with the project. So there's 3 examples that we'll go through here that I'm going to be talking about. Also the subcontractor interviews and pre-qualification, we'll be talking about that, how that process worked for both the ready-mix supplier and the formwork system suppliers. We'll describe the 3 mock-up phases that we went through for building the project, which from a small scale for the mix to a full scale for the whole element. Going on, we describe placing and finishing requirements for the vertical cores and columns, horizontal work for the slabs, and vibration using external systems that helped us in remediating and mitigating the amount of surface imperfections and bug holes that typically happen with any time you're trying to do architectural concrete. By the way, this was a highly developed self-consolidating concrete mix that was flowable and could hold together properly, and that was one of the reasons that we wanted to. So we had to use that as one of the main components in our design. I'm also going to be talking about stain protection and resistance and things that we went by to mitigate the potential for staining of a white concrete, obviously. Formwork sheathing attentions, the concerns that we had with the edges of the plywood, the tooling and tools selected for cutting and fitting, detailing for the edges, the packing and protection for transport, and selection of a release agent. Finally, there's cleaning and patching and a mock-up review. This is the outline essentially of the building and a couple of projections of renderings. And I was going to let Ryan just explain a little bit here on what we wanted to, some of the concept of the architect.
Sure, Lloyd. Thanks for the introduction. And just like to say as we get going here that, our office has done a lot of concrete buildings over the years. And the process we went through with Lloyd in Colombia was far more, I think, involved and rigorous than I think we'd gone through on a lot of other projects. And I think it's now become, I think, the kind of standard process that we insist on going on with all of our concrete projects. And it's been really helpful, I think, as you'll see in Lloyd's presentation, I think getting out of just specifications and standards and being a lot more hands-on. I think with all of the players, from the client to the concrete supplier, to the formwork supplier, to all the subcontractors, and really getting everyone on the same page to participate in the process and to understand, I think, what the aesthetic goals are, and the requirements and standards that we expect for the project. Just to speak for a very brief second about the design and some of the things that I think got us to the images you see on the screen. There were two, very unique conditions present in Bogota that I think helped kind of shape the design you see. The first is that something that was very surprising to us and very different, I think, for people who are used to working in a northern climate, is that the climate of Bogota is incredibly consistent year-round. It's almost it's about 70 degrees Fahrenheit, every single day. It rains a little more, some seasons than others, but it's remarkably consistent. And so we found early on is that it's actually more challenging for them to get heat out of buildings than it is to keep the cold air out of buildings or the heat out of the building. And so in the mechanical design, we have passive ventilation. We use single pane glass. There's no IGUs. But what that means for the concrete is that it didn't require thermal breaks. So we were able to achieve something like you see on the screen, where we've got an expressed concrete structure, the columns and the slabs that go right all the way through the building. There's no thermal breaks. There's no, we weren't worried about, the cracking from the temperature or transferring of cold air into the building. So this is something that we really couldn't achieve in New York or Toronto. It's a very unique opportunity to pursue this kind of structure. Another aspect is the kind of the zoning envelope in Bogota. So the way they calculate zoning for the buildings is this kind of triangular pyramidal envelope that comes up from the property extents. And so the normative way that people address that is to have one or two setbacks in their buildings. So most of the buildings around our site are maybe 4, 6, 7 stories tall. They have one or two setbacks, but they fall comfortably beyond that or inside that envelope. For us, we actually were just excited by that opportunity and followed it much more closely. So you can see the building really is a pyramid in form. And by doing that, we were able to achieve 15 stories in height. So the building's much taller than any of the surrounding buildings. It's much thinner. So by the time you get to the top floor, it's really just a single room, single offices or boardrooms on those top floors. But it's a very striking form, and that was driven really just by the zoning envelope. And then one last thing about you see that image in the center. It's a kind of just schematic rendering, but you'll see the ceiling is white concrete. So the ceiling is actually the expression of those concrete slabs. And I'll say, you never realize how many things go in the ceiling until you try and make it just a pure architectural concrete surface. So I think that was one of the constant coordination challenges in the project. But it's kind of the inversion of how you typically think of a building or an office space, to have an architectural concrete ceiling. Everything is in the floor systems, the conduit. But that was another real challenge in the project.
Okay. Yeah, thanks, Ryan. So this is just if you're familiar at all with Bogota, it's essentially way up in the mountains. I believe it's somewhere around 7,000 feet in elevation, and it's essentially right up against the mountains, and it's on a floodplain more or less where the city of Bogota is. But the mountains, as you are right at the edge, And essentially the location of the building is in a very high-end region of the city that's very predominant with shops and restaurants and parks. And the building is right at the junction of a couple of the main thoroughfares in Bogota. So it was a very high-profile selected location. The inspiration for some of the architectural rendering and the process here is from a project by OMA in Netherlands, and this is the building Fondazione Torre Prada in Milan. Maybe Ryan, did you have anything you wanted to mention about this, or about how it focused in on, this was one of the focused buildings?
Yeah, I think this was this is the building that I think we first sought out as the best example of white architectural concrete that had been done, around the world. And so I think Lloyd, you'll talk about, I think your team went there, documented the building, I think some of the successes and areas for potential improvement. But yeah, from very early on, having a white building was actually, I think actually came originally from the client. They wanted to have a white building. They wanted to have a very clean, pure, modern building. And white concrete was something that had been on our radar for a long time. And so I think it was actually the perfect opportunity to pursue this. And this building, the building on the screen is a great example of that.
So in order to what we wanted to achieve here, we performed a local and international review of existing white concrete architectural buildings. Special attention to measuring the whiteness and canvassing ready-mix proponents to select materials most beneficial to obtaining the optimal white color. We were to produce a specification for ready-mix concrete and concrete forming and utilize standards and tolerances in keeping with the state-of-the-art and practical limitations. So as I mentioned at my introduction, is the initial thing we did was a reconnaissance and a review of a number of white buildings that would be characteristic of what we were trying to achieve here. And of course, Fondazione Prada was one of the ones, and you can see with the sharp lines, the white concrete, and a lot of the concrete expression, both for the ceilings and for the walls and the core walls. So it was one of my colleagues, when we were over in Europe, went down there and took a whole bunch of pictures just so we could get an idea on what some of the concepts were and what we were trying to achieve. Now we looked at things what we wanted to do, and also things we wanted to try to improve upon. So you can see in the one on the left here, the joinery between the panels of the formwork was somewhat lesser than would be desirable. So it was a function and something that we looked at that we had to try to improve upon. Similarly, you get imperfections, as to the photo on the right, where you get bug holes or blowholes, as they're called. And again, the variation in the joinery between panel to panel, where there was a dislocation, which we wanted to try to reduce as much as possible. And again, showing a couple of things, even though it was a very well-renowned building, there's always things that you look at and you go, well, I'd like to improve this, or we could do better, and all that kind of stuff. So, for example, the coloration of the tie holes on the photo on the left, where the color wasn't matched properly, or again, the joinery between panels, as I was saying. So these are things that we wanted to try to improve upon. So Then on the ceilings, again, as with anything, when you're forming or building these, of course, the tradespeople have to get onto it because they have to set the rebar and they have to set the forms and they have to put the release agents, so they have to tie the panels together. And with that, of course, then there's opportunities to impress discolorations or stains or contaminants onto the surface of the formwork. So that you can see some of these in these pictures here, and these are again things that we were looking to try to protect against. The photo on the right, you can see on the edges where some of the sharp corner edges had broken off, and so they'd have to patch to try to make it look okay. Again, we look very carefully about how we're going to protect these edges, the way that we're going to try to pull the forms off. So in fact, we don't impart a torquing so that damages the edges. So that was again something that we learned from looking at the project. This was a building in the outskirts of Bogota. A junior college, or it's actually, quite frankly, it's a middle school, I guess is what it is, for people, private school, very nice campus, beautiful, all in white concrete. And so we walked through there and looked again there to get the impression, and the impression of the white concrete really stood out in the area and made it look really amazing. We met with the local architect, who was the one that was responsible for building this in the various stages they built in. And we picked out some really good ideas, and also some that we thought we can improve on. One thing, the whiteness was not as profound as we were looking for, and we went through ideas on how we could improve that to make it so it stood out. I think it's important to mention that in Bogota, a lot of the architecture is brick or beige in color, so you get this predominant beige color throughout the whole city. And one of the things the owner and the architect wanted to have was to have this profound white, stark building to stand out from the rest of the cityscape. So it was very predominant, and we learned from. Again, this is another. It was I'm not going to be able to pronounce it very right, but Santa Maria de los Caballeros. Which is again I believe it was a school, and it again had some very profound and beautiful features. The paneling for the formwork and the tie holes and whatever, they made the concrete as the architectural feature. One of the things that we were looking at in this, and we noticed quite profoundly, was on the horizontal surfaces, like you can see in the abutment wall here, where you're going down the stairs, and a bunch of the other ones, they trapped the contaminants from the air. There's a fair amount of pollution in Bogota because a lot of cars and stuff and everything. So as you get settlement of that onto the top surfaces, and then if it's not properly drained away, you end up with the staining down the front surface of the verticals when the rains happen. So this pointed out also the importance of being able to drain away from the vertical surface and not having a buildup of contaminants, especially running down the vertical surfaces. And again, here was a downtown Bogota in the other end of the city. And this was a university library, University Tadeo Library. Again, a white concrete structure. Most of them tended to be slightly beige in color, and that was characteristic of the sand that they were using. And the white cement was slightly off of ideal white. So it again gave us a good impressions on what could be done, and we did look at this, and we had a lot of things to talk about and to discuss with the project team about what we wanted to do and what we didn't want to do, and it very much helped to see these reference installations and to go to them and look at them and tour for sure. This is another building close to where the headquarters of the that we were building for Cine Columbia. One that we'd been given commenting on, right in the park, 93, and they had some amazing structural elements, diagonal columns, a lot of exposed concrete or whatever that really set out to make an impression of the building. And we looked at that. One of the things we looked at though was the potential to reduce the bug holes at the top surface of the form of these columns, which tend to predominate. We used they used an SCC there, but there is a tendency for, especially in the top of a slanted column, for the air pockets to congregate, and you do need to have a mechanism and a means to deal with this. So because of that, we looked into, which I'll talk about later, into external form vibrators to try to reduce the presence of these bug holes. But again, as you can see from the building, it gave a lot of nice impressions of what you could do with concrete and how it can work in an architectural design. These were some of the things that we pointed to about what we didn't want to have happen. You can see on the photo on the left, and if you can see the red arrow, these were columns that we were pouring, and so you'd pour them, and then you'd wait to form and build the rebar cages, and then you'd pour again. Well, what happened during the interim between the placing of the bottom part and then getting ready to pour the top, of course, you would get the contaminants from the air, windblown air, onto the top surface of the column, and then also the rust from the black steel running down, being carried by the rain, and then down onto the surfaces of the concrete. And this was obviously something that we didn't want to have appear, especially on the white concrete building that we're looking at building. Similarly here, you can see on the underside at the Santa Maria de los Caballeros building, some of the soffits. And again, there was a staining on the underside of the soffit from the runoff and the oxides that were building off of the rebar while they were getting ready to form. So we learned that was a thing we had to deal with. Next thing is on the ready mix prequalification. We're going to talk about that a little bit. We knew that this was a very special project, and we also knew that we were pre-qualifying a number of ready-mix producers to be able to supply the concrete in Bogota for the building. We asked that there was a number of technical considerations that we went about. And one of the things that I built into one of the meetings that we went through was requirements for the hardened properties, there was a strength requirement, and there was a permeability requirement. So in fact, we don't absorb a number of the contaminants. There was a shrinkage requirement requirement for modular elasticity, so the movements are constrained. With a lot of the aggregates in Colombia, in Bogota, tend to be slightly to moderately reactive to ASR. So I had to ensure that, in fact, we did testing to prove out that, in fact, with the blend and the mix that we did, we were going to use, that, in fact, it would not create a reactive mechanism that would lead to deterioration and that down the road with time. So we made sure that we did testing for that. We also were very, as I indicated, very concerned about the color. And so we devised a requirement based on a spectrographic CIEL rating, where the ratings for whiteness go from 0 being completely black and white, and 100 being as white as you can possibly be, which is a measure of reflectance, basically. And so we were looking for readings greater than 90 for this concrete mixes. So this was communicated to the proponents. Plastic properties, it was SCC, so we wanted to make sure that it was flowable, that it would resist the potential, the rheology or the viscosity was low enough that we would reduce the potential for bug holes, and that it would be non-segregating. So we had controls on that from the rheological properties. We needed to ensure that the working time for the concrete was allowed 4 hours. So special provisions had to be done with the design of the mix to ensure that we got 4 hours. The reason being, in Bogota, traffic is a real problem, and especially during the middle of the day and during rush hours, you can get deliveries taking anywhere from 1.5 to 2 hours from the batching time. So we had to make sure that when we got this, we weren't getting into a problem of having to reject due to time. So we made sure that it was designed from that perspective. We also had a requirement for production where when we went to review all the installations, so we reviewed 4 proponents. We checked their production capabilities for their trucks, that they had dedicated trucks that would be able to supply only the white concrete. We didn't want to have contamination from previous pour of gray concrete that would mix in with the white concrete, of course. The aggregates had to be stored in a manner in bins that separated from the other aggregates so we wouldn't get cross-contamination there. Cement storage, again, the silos had to be separated, and we had to make sure that the means of conveying into the batch equipment was such that that it would not segregate or contaminate from the normal gray concrete. So there was a number of issues that we had to deal with that we discussed with the ready mix proponents in our reviews. Our 4 proponents we chose, and that was with help with our construction manager, who was local to Colombia, and the architect. And so we came down with 4 proponents who were to supply, that we chose to pre-qualify for the concrete. And that was Holcim, Ultrasem, local from northern Colombia, Argos, and Cemex. We had special specifications for the white cement. which we identified an equivalent manufacturer that had properties that were appropriate. That was by Lehigh. And we also limited the amount of coloring oxides in the white cement. You can see in the second item here where a number of the oxides that would create a color were limited. So in fact, that we did ensure that our white cement was the one that we're looking for. When we discussed, as we were meeting with all our proponents, with the various ready-mix producers, one of the problems that we found was that it was pretty hard to communicate that we really wanted to have something that was iconic and that showed something that's from the rest of what was resident in the region in Bogota. And a lot of times when I was the initial communications, it was always, well, but that'll be expensive, so we can do this and it'll be cheaper, and that's what the owner will want. But the owner was very explicit. Every time he talked to me, he says, Lloyd, this has to be something that's going to be the best. And he says, you've got to do this for me. So I figured that, okay, what we're doing is we have a communication problem here where the ready-mix producers were always thinking that price was the predominant factor. So I said, you're going to do something for me. We have two mixes that I want you to provide for us. We were going to be doing mock-up 1, which we're going to talk about. I said, I want one mix. It is going to be the best you can do. You are going to hold out all stops and you don't think about the price. I said, the other one, you can build in what you consider, okay, that's too expensive, so this is more less price, so it's not as good, but it's probably okay. So I said, I'll tell you what, I want you to produce two mixes for me. I said, one, I'm going to call the Gucci. And the other, I will call the Walmart. And so you are going to provide two mixes to me, and that is what we're going to get to choose for the suppliers, for the owners to review in our mock-ups. So that was the way we did it, and surprisingly enough, this worked out very well to communicate, because then all of a sudden everyone got it. There was no question whatsoever about the issues. I'm going to ask Herman to speak a little bit right now. We went through a pre-qualification process, and he's going to discuss a little bit about what he went through in his setup for the concrete.
Thank you, Lloyd. Yeah, from the point of view of the concrete supplier, we understand the message from Lloyd. We have to change our definition of white concrete, because for us, white concrete has a specific image in our mind. For example, one that I chose, for example, to Lloyd, a quantity and amount of sand in our plant, and I told him, this is our white sand. He walked to the sand and he put his finger and signal exactly and identify exactly many of gray and black parts. Very few, and he told us this is not white. So we have to change our mind to understand what exactly our client wanted. So we began to think in that way. So we look for different raw materials. So we have to look for a special cement, our whitest cement, and I am talking about around the region. We have to look for also different kind of aggregates. We visit many quarries in around Bogota, And finally, why we identify one sources, which is really, really white. And this aggregate had not been used before for concrete. So we have to explain to our supplier how to make sand in a bigger scale. So finally, we have to develop, and our chemical admixtures have to we eliminate the pigment that we use to identify this substance. So all the effort was made to obtain a level of whiteness, the widest lemon, the Gucci concrete for Lloyd and for the client. So using this kind of movement, we developed a special concrete, a new special material that had not been used before, had not been obtained before. So regarding the plan, we have a new plan for this project, exclusive for this project, because we have to eliminate, for example, the fleece and the roots from the trees. We have to storage the sand in a very different way than the usual way, in a close way. So we have to dedicate two special trucks only for these trials. So this is another way to things where the price is not the variable to follow. It's not the price. Of course, the price is important, but it's not the main parameter which governs all the decisions. So this was a very nice exercise, and I think finally we understood what our client wanted. That's it, Lloyd.
Thanks, Herman.
Okay.
So anyways, what you have here is this was some of the areas, and you can see the sand is actually very white that we eventually ended up going with. It's so because of the whiteness of it, we had to make sure that it was covered and protected from wind-blown contaminants being driven onto the stockpiles, even while they were stored at the ready-mix plant, because of course, then if that mixes in with the sand, that's going to affect the color. So all of that was very carefully done. We checked through this was we were doing a mock-up the next day, and we made sure that everything was clean and uncontaminated. They shut down the plant like 6 hours the day before and went through a whole cleaning mechanism to ensure that everything, right from the conveyors to the batchers to the front end loaders to everything, was clean and devoid of any of the contaminants from the gray concrete. On the right here, we have it's a bag of titanium dioxide. This is the product that we used to super enhance the whiteness of the concrete. And this was just an example of it. I'll talk about it a little bit later, what the attributes are, but this was a key component in our mix to give us that brilliant white, plus the sand. Okay, so what we also had to do is we also had to, besides just the ready mix producer, we also had to ensure that we brought the formwork suppliers on board too, because there was a lot of special items that had to be dealt with the formwork supplier. We wanted to ensure that those joints that I mentioned earlier were not apparent. We wanted to make sure that everything was clean, that the lines were true and straight, and we didn't get movements or deflections in the installations. In that we had the slanted sloped columns, that created the need to have a specialized design for the formwork systems. So we met with we had three or four formwork proponents, And we met with them to explain to them what we were trying to achieve with the 90-degree corners, with the exposed ceilings, with the lack of joints between the panels, and with the customizing for the slanted columns. Ryan's going to speak briefly here on, he's got a couple of slides that he's going to talk about the structural design philosophy.
Sure. Just to zoom into a little bit here, so everyone can understand, I think all of the various conditions we face, we had to address for the formwork. A lot of them very unique. Kind of zooming out for a second. One of the interesting aspects of this project is that when we started in concept and schematic design, we initially worked with a team of international engineers who we work with on all of our projects, including a mechanical engineer based in New York, and a structural engineer, SOM, who was working between their offices in Chicago and London. And so one of the interesting aspects of this, which we'll see on the next slide, is that SOM, so Bogota has is a very high seismic activity area. It's a seismic design, and how you resist that movement is a very high concern. SOM designed a very rigid building. So the building, you can see these very thick perimeter beams in blue on the left-hand image. So those are over a meter deep. They're 70 centimeters tall, I think. So they designed a very rigid building that wouldn't move as much in a seismic event. After SD, we switched over to a local engineering team who works in these conditions, day in and day out, and they designed a much more flexible building that could go along with any movement in the earth. And so the overall concept stayed the same, but I don't have a drawing of it here. But these interior beams that are kind of spanning across the floor slab became diagonal, going from point to point. The columns creating more of a web, kind of that allowed the building to kind of more loosely move. Lloyd, if you can go back to the previous slide real quick, just to point out a few other. So yeah, with the floor slabs, we have these enlarged perimeter beams, which were also a challenge. I think Lloyd will talk about later on the challenges with catching the water there to prevent it from dripping over the edge with the pollutants. The columns were obviously a challenge for pouring. And then we have the building core in red on the left-hand side here, which again is an architectural concrete surface, and that provided the lateral stability in the building.
Yeah, one of the other things too, Ryan, is that, and this is probably a good drawing to show, is that in that we didn't want to drain the water down onto the vertical surfaces from especially the perimeter eyebrow beam, I'm going to call it. So when rainwater would go, it would land on there. So we wanted to make sure that it drained in and down through a drainage path through the building. The way the building was designed with the core, the only place we could bring it down was in the core. So we'd have to run the water and the drainage channel all the way around the perimeter to one or two points in the core where again it could run. So this created issues with the size of the drain and the slopes and whatever else, which created I think we talked about this in our meetings for, it must have been a year and a half at least before we finally came up with a solution on what we're going to do. And it was one of the more challenging items in the whole building.
Absolutely.
And that's your.
Yeah, just some images here about that seismic motion.
Okay, so and then we this is again things we were talking with the formwork producers, and we again showed pictures of the Torre building in Milan. Some of the things we wanted, some of the things we didn't wanted, like the discolorations, the panelization of the individual sections of the wall because of the misalignment of the forms. Obviously, the surface imperfections, discoloration due to different timing and planning on removing of forms. So these were all things that we discussed, and we talked to them about what we didn't want. In order to deal with the misalignment of the face sheets, we went with a double layer of plywood where there was a base sheet and then the face sheet on top, and they would be staggered so that in fact the joint between the face sheets would be fully supported by a layer underneath. So that was one of the things we looked at. We also looked at vertical vertical elements, the core and the columns, to extend 20 millimeters above the bottom faces of the slab soffits, so that in fact we could have a nice crisp line between the horizontal and the vertical element, and not stop the column or the core below, so you would see a ragtag line. So that was an important thing there. Obviously, we talked about the corner formwork detailing, how we wanted to have these sharp, clean lines and 90-degree edges, and how we wanted to ensure that the joints, when they did come together, were tight and didn't allow any leakage through paste through the forms at the joints. So the next phase we went through was on, and so we said the specification for the Phase One Mockup, which was essentially a series of panels, and this was for the ready mix producer to provide, which would be 24-inch by 24-inch by 2 inches thick, which would be cast with the types of concrete that they were going to supply to us, both the Gucci and the Walmart. And these would we had an order somewhere in the order of, I believe it was 28 panels submitted by all the proponents, with different variations sometimes of the Gucci versus the Walmart. And we would use the colorimeter to measure the performance. The Formwork suppliers that we chose for pre-qualification were two out of Spain, Sten and Alsina, and Perry was the other one. We mentioned to them that they would their scope of work for the suppliers, they would do all the engineering to develop the shop drawings for both core walls, columns, slabs. They would supply the equipment for forming and falsework support. They would lay out and supply the facing materials and backup plywood on their shop drawings, and they would inspect and verify the installation. So we were putting a lot of the impetus on them to ensure that we got the product we wanted, because with the labor force that would be doing the installing didn't have that expertise, so we wanted to make sure that it was put clearly on the onus of the people engineering the stuff. So for the review for the Formwork people, we needed them to prepare a set of engineering drawings showing concept for slabs and beams, columns and column to slab joint, and core walls. We mentioned to them that modular systems that show a distinct jointing pattern are not acceptable. We wanted a clean joint that did not pervade throughout the look of the building. We mentioned that for our columns, there will be no exposed ties or any pattern. For core walls, a drawing was presented and showed a recommendation for tie pattern and stripping strategy. So Elliston, our company does formwork also and self-perform. So our engineering group drew up some concept drawings just so that we could discuss that with them. Again, the corners are to be sharp, 90 degrees without a chamfer. And so the selection of the preferred proponent would be based on the technical capacity of the proponent, based on their project staff, and the quality of the engineer's shop drawings described above, the ability to provide equipment in an expedited manner, and the overall cost of the submission. We had a mock-up phase program, which I talked about in phase one, about the panels that were to be produced. So what we had is we had a series. What I also asked for in the specification was that they supply samples of all of the raw materials that they use to make up their mix design. So here's an example of a number of the submissions that were made by the different proponents: Argos, Holcim, Ultrasem, and Cemex, and their samples. So for example, Cemex had 5, Argos had 4, 3, and 2. So, and here were their constituent materials, which we found was a very useful thing to have, because we could see first from a perspective how they came upon the whiteness of the color, and secondly was a control down the road. In the event that something changed, we had a retained sample to verify if something was going to change or be adjusted, because we wanted to have a uniform looking building. Mock-up phase one, all the panels were produced and set out on a black background, and the project team, we reviewed and walked around to select what looked best. And so Munir, who is the owner, and Thomas is here somewhere, was the architect. Between them, they chose the panels that they chose 2 groups panels that were chose to be the best going. And we measured both by visually looking at it. We also had a colorimeter, which measures, as I mentioned earlier, based on a scale from 0 to 100, the degree of reflection that would happen. There's a light that shines on the underside of this device down onto the sample, and then it measures in the scale up here the amount of reflectivity. And the value here is the whiteness is the L value, and then for the one that I'd measured there, it was 83. So for a number of our samples here, you can see the various levels. We had anywhere from 77 up to 92 was the top value. And ultimately, we chose from 2 proponents, Argos and Cemex, to move to phase 2. In that we wanted to still have more than just one, but we also mentioned to Argos that they were going to have to improve their numbers. Again, these were the samples. Typically, what we did is we wrote in red the number from the colorimeter, and then we would visually review on top what we thought the best was. And invariably, and actually, quite frankly, what happened is the highest number was the one that was picked as the best sample. So it calibrated very closely. One thing I wanted to point out between the blue numbers, and you see there's for the Cemex samples and the Argos samples, there's a red arrow and a blue arrow. The only thing different between those 2 samples is the one with the blue arrow had the titanium dioxide included, and the red arrow did not. So you can see that there's an effect of anywhere from 5 to 8 increase in the number based on the fact that you've got this titanium dioxide. Just a little bit of background for those who may not know, titanium dioxide is actually a photocatalytic, and it reacts with ultraviolet light from sun and water and with a contaminant to remolecularize to the point where the contaminant dissolves and is blended into and goes away as water vapor. So so they call this smog eating or self-cleaning is what another thing is. So it's a beneficial attribute also. Besides having the color, it actually is something that's friendly to the environment, and it actually enhances reduces the pollutions in the air to a degree, which is very beneficial to this photocatalytic response. Based on the results of Mockup 1 and the selected color samples, as I said, we chose 2 proponents who would then move on to Mockup number 2 or phase number 2. Phase number 2 was we were to produce large samples, columns, to identify the type of formwork surface that we would use for the facing materials. So what was chosen is there were 4. We chose 4 formwork materials. There was 3 that were phenolic HDO plywoods. One was Savannah from British Columbia. Another one was Super T from Colombia, and a third one was another Colombian phenolic, and the fourth was a stainless steel. The makeup of we made some columns. That was a drawing that we drew up, but we eventually ended up with it straight or vertical. But essentially what we had is we had the surfaces where each of the 4 surfaces of each column would have one of the potential formwork surface materials, whether it be one of the 3 phenolic plywoods or the stainless steel. Some of the detailing that we did was to make sure all the joints were pinwheeled. So in fact, the joints would be as tight as possible, and there would not be a breach or a lap. And we made sure that the joints were pulled together tight by our forming and our ties. These were the 4 facing materials that were used, as I indicated earlier. The one from Poreform PH from Savannah Plywood, Tablero Premium, and the Formuletta product. This is we use Knoxcrete PCE as a release agent, which has, from our experience, has been one of the best that we've been able to use for architectural purposes. It's very thin film applied, very high rate of coverage, and so it's a reactive type release agent that's very, very thinly applied, and gives you a very beautiful architectural surface. This is the stainless steel, one of the phenolics and a third of the phenolics, a second of the phenolics that were chosen. And then here was the Savannah plywood. These are the samples that we produced, 3 columns. again, with each had the surfaces, the 4 formwork surfaces on, and we had 2 mixes from Cemex and 1 from Argos. And so from that, we measured the results. And came up with, we measured with the colorimeter, and as you can see, most of the numbers were fairly similar. The main effect that we found was with the surface finish and the smoothness of the various formwork types. And we found that both the stainless steel and the Savannah plywood were by far the most beneficial of the type of formwork surfaces we used. So ultimately, we chose the Savannah plywood. Overall finish quality was superior to the other 2 plywoods. And the stainless steel had a very smooth surface, but it was disqualified because cutting and fitting on site would be impossible. Screw fasteners were required to hold in place, and the cost was much more expensive than the Savannah plywood. So we chose to go with the Savannah. Basically, after we had done all the testing for the information, the hardened properties of the concrete and the plastic properties and the review of the color and everything, Cemex was chosen as the proponent that we move forward to go with for the project. Next phase was phase 3. That's where we do a full-scale mock-up with full set of drawings and a mock-up that would show the various elements in the building, both the horizontal surfaces, the slab, the perimeter edge beam, the slanted and vertical columns, the core walls. All that would be built into our mock-up, so that then we could learn and see the benefits of the strategies that we were going through. This was a schematic or a 3D drawing of the mock-up, and as you can see, we have the one elevated slab with the perimeter beams, slanted columns, concrete core walls, 90-degree corners in all the elements, and all the these were a concept of the shop drawings for the slanted columns by who we had chosen Sten as the supplier for the formwork, because they proved to be the most beneficial or the best proponent of the others that we chose to review. So they had a slanted, they had an idea that they were going to go with fillers into a normal straight column and build that to create the slanted columns. This was proven out in our mock-up to be really an impractical method to build. It was very, very heavy. It was hard to put in place and to align because of the large surfaces that you would have to be able to set on top of the previously cast slab, and any miss level or out of a line would reflect and basically replicate a movement in the filler, which would create a problem with aligning and closing the joints. So after we had done the mock-up, we realized that we had to move in a different direction. So we moved to a 4-panel system that was much more flexible and had a series of, they had to adjust and to build a special side bracket to allow for setting against the whaler and the slanted beam that set the formwork panels in place. So that was it took the mock-up to prove to the supplier that wasn't the way to go. So we ended up with something that's a lot more feasible and gives you a lot more latitude, easier to place, easier to lift. We ran out of crane capacity with these large columns if we were going to go to the extreme end of the building, and so that would have been a challenge to move these. To create architectural pressure within the thin 1.5 millimeter joints, as I mentioned, we needed a double layer of plywood. So essentially the base layer would be, as you see down in the bottom right of this drawing. These were placed first, and then the second layer, or the face sheets, were placed secondly, as you can see here. So we placed the primary layer, and then the top layer of the face sheets were placed afterwards. Issues here related to joints and being able to create an issue so we didn't get a large joint, and how did we prevent them from any contaminants from getting in. We also had an issue which I talked about way back when, is the staining created by the black steel, the oxides being run off by the rain. We were able to convince the owner and the architect that we should really move to galvanized steel, which would then negate the potential for having any oxidation of the reinforcing steel, and it meant for a lot cleaner thing. But because of our white iconic structure, we had to go with that way. So all of the reinforcing steel was galvanized steel. And again, a lot of the reason was there was lots of rain in Bogota. The steel would get oxide, and then it'd run onto the vertical surfaces. Here we're preparing our formwork panels. We had a sort of a temporary shop that was run. We had two subcontractors working for the installation of the formwork. One was a carpenter who was specializing in creating the joinery and the geometry of the face panels. The other was responsible for the more less sophisticated of clamping the forms together and setting the false work and shoring and stuff in place. What we found, though, was that in a lot of cases there was issues that we had with the joints and the edges, where the joints were just we couldn't get them tight as we wanted them. And then we realized as we went into this that the surface imperfections of the manufactured plywood were such that we were getting a gap of anywhere from a 1/16 to an 1/8 of an inch, just due to the fact that the plywood edges were not properly treated and sealed to prevent swelling due to the moisture. And here you can see is a quick summary of what I was talking about, is that the rate of expansion and swelling of grain radial to tangential is significantly different, and a radial grain half the value of the tangential grains. So if in fact we don't have these edges sealed properly, one of the grains will expand significantly more than the other, and then you get this gap that's created when you try to butt the samples together. You can't do that. So what we did is for the later we talked to the manufacturer at Savannah on what they could do, which I'll show you in some slides. But for what we were doing now, we had the freshly cut layers. We had to make sure that we used a high solids acrylic paint designed for outdoor exposure that we painted onto the outside edges as they were cut. The other thing is the method that they use for cutting the plywood, cross-cutting or ripping the sheets to size, was not, they used a handheld quick cut saw, and because of the inability, even though they ran it along a straight edge, their hand was not able to keep it in a true plane. And so we got both a waviness and a twisting. So for the production, we have to go with a panel saw, which essentially, as you can see here, has guides for connecting the saw blade, to which you can slice the plywood in this direction or twist the saw and push the plywood through to create a ripping action. But now you're controlling that movement, and you don't get that variation done by the handheld. So this is a necessity that you have to achieve these straight joints. And this is just a sample showing what's happening and how the gaps between the joints were. And there's the backup plywood and how it was not, the edges weren't sealed, and then of course that you get this movement. This is a photo showing the slanted column and what the size of the element and how hard it was to try to get it to set flat on a surface. If we tried to plumb it and to set an elevation, if you had to twist or move this in any way, of course, part of the support would lift up, and you would get a gap in the joints. So this was, as I showed earlier, was a modified slanted column that we went with that will be a lot easier to fit. This is the installation of the plywood at the top surface, and one of the things that was apparent is that they were cutting the plywood up there on top as they were trying to fit it around the joinery, and it's still, the joints weren't as good as we wanted, and the gaps here, again, panels was not appropriate. We also use a sealant to put between the joints. Now here you can see this is a picture just probably about an hour before this picture was taken, and this was them cutting panels close to where the hello? Oh. Yeah, cutting panels, and the wind would blow the sawdust down into these joints, and then we had a rainstorm, and guess what happened? We had a rainstorm, and then the sawdust was running down onto the surface of the element. So that was a good lesson learned, that we had to ensure that they did not cut up by the area of the installed work, that they had to go away from another area and make sure that then you bring it back. And the other thing is to make sure that we seal. So we used a sealant, it was I think I've got it in the next picture. Here it is. Yeah, an acrylic latex that if we set it low, about an 1/8 inch below the top of the surface of the panel, and use this latex silicone caulk. You're able to wash it and clean it off with water and a rag, and it doesn't leave a smear or a blend of material onto the surface, which again can affect the architectural look. The other thing that I talked about was needing to deal with the surface imperfections and the air pockets that would naturally congregate, especially in the slanted columns. So we had to go. We engaged Wacker Neuson, who's a supplier of external form vibrators, to come up with a system and a methodology to which we can utilize this on our construction process. So we went with these. This is a clamp that the external vibrator is bolted into, and what you will do is you can then use this to set onto the vertical beams of the formwork and impart the vibratory loads. There was a method on how essentially every 50 centimeters we would move. We would use 2 sets of external vibrators, and we would leapfrog. So that in fact, every 50 centimeters, we had a series of vibratory screeds or external vibrators that would impart a load into the surface of the concrete, spaced appropriately through the beams, and remediate the potential for this bug holes. The optimum vibration was 6,000 RPMs, and we did a series of tests to determine the optimum duration for impacting this load. So we went with a 30, a 50, and a 60-second duration to measure the effects and see what worked out the best. We were worried that if you do too much, you may segregate the SCC and create some problems that way. But ultimately ended up with the 60-second duration was our optimum, and that's what we went to go with. And this was just them going through the motions with the, basically you have a rheostat and a frequency adjuster that eventually into the external vibrator, which will then control the RPMs. And with this, we would turn it on and turn it off for the duration that we were looking to achieve. Placing these walls, okay, that was a challenge too, because again, we had SCC, we were using that, but we wanted to ensure that we got the minimum amount of imperfection in surface. So we used a Tremie process to place the concrete, and we would place it at regular intervals of approximately 3 meters on center and start from one end and move to the other end to be able to pour when we're pouring our walls. We used a 150 diameter Tremie pipe, which allowed us, we had to work with the engineer to ensure that we had the spacing between the thinnest walls, so in fact we could place that, but he was able to move his steel and make sure it worked, so we had ports every so often that we could place our concrete through and use the Tremie system for placing it. The Tremie basically was made up of a hopper and a spout, a receiving cradle that you set the hopper into, and then you had an elephant trunk with ports that were cut on either side at 500 millimeters on center, and these ports were 200 by 200. So what you would do is you would place the concrete, and as the concrete rose, it would then flow out of the closest port. And what you end up with is a very smooth laminar flow without a lot of chaos and movement in the concrete. So this gave us the best finish that we could achieve. Here we are. We're doing we're starting our pouring, and as you can see, there's the concrete, and it's definitely white. We used a pump into a spider crane and into the hopper is how the process was used to place it. This is again a picture of the placed concrete. Here around the perimeter here is our drainage channel. We did a mock-up of our drainage channel to drain away to the core. And these were supports or brackets to support the drainage channel while we were placing the concrete. And this plywood here is a cover over top of the drainage channel, so we didn't get concrete into it. So obviously the brackets had to prevent the uplift from the channel when it rise and displace from the movement. Again, it was SCC, so it placed, but you can see how it worked. And we did get some discoloration in some of the areas. The picture I showed you where the rainwater carried the sawdust in. Also, we found when we used sealant in any of the joints, if the sealant was flush with the level of the formwork, the contaminants from the air would be attracted to the sealant, and we got a black line. So we realized that we had to clean it to make up for the mock-up. But two is we had to ensure that in future placements that we move the sealant bead back at least a 1/16 to an eighth of an inch below the level of the surface of the formwork material. So we used a product that worked very well. We tried a number of different products, concrete bright, and you can cut it back to 2-to-1 or 3-to-1 depending upon the type of contaminant you had. But we had a very, very efficient person and that was able to do the cleaning and the patching and stuff for us. That gave us a very beautiful looking element. Here we are, and this is our mock-up placed, and this is our review by all the parties from the owners. There's the architect and Rodrigo, the project manager, and there you can see how it stands out, that white color from in the building, and the sharp corners, the abrupt finishes there, and so it gave us an element that really I know the architect Thomas was very, he thought it worked well, and it really does stand out as something that is an iconic type element. There's the perimeter eyebrow beam from the bottom. And looking at the drainage channel that we had. So we pulled off the covers and everything. It was stainless steel cover, and how it blends and melds with the building as such. So what they're doing is they're standing there. This is the curb area where essentially the glazing would be set, and pretending that you're looking as if from the window looking down, and what that visual impression would be. Again, the stark corners and edges and the coloration, the sealing. Some of the black was from the sealant that was too proud, but we were able to clean this off to give it a very, very good impression. Just quickly, we had to deal with the manufacturer of the plywood, because the first shipment that we got, this is what happened. It was damaged. The edges of the plywood were, you see, the paint was rubbed off. There was areas that were damaged due to the forklift handling of the pallets out of the container. So we modified the protection and the handling mechanisms with Savannah. Here you can see what they're doing is they're setting the 50 panels into and aligning them and setting them in place. Then what they do is they place a press to push down the panels, and then they spray paint all the edges. Is the process for doing that. Because of our concerns with the quality of the edges, they changed the paint to a higher build solids material that worked out a lot better and stayed with a lot more of the concerns. They also had special care and attention to the milling process that they did when they cut the plywood. So in fact, they would get the best surface they could. Then for shipping, we have to protect. So what they did is they put plywood samples on both the edge, the top, and the ends, and the underside. So in fact, it would prevent any damage to the edges from shipping and handling. And Silvio, that is it. Any questions?
Gosh, that was fantastic. That was a great presentation, Lloyd. Maybe I can start off. Lloyd, you went through quite an elaborate process of shortlisting almost everybody on this project. And
yeah,
how was that? I mean, it was construction management, but how was that process managed? Because generally we're used to shortlisting one or two subcontractors, but you were actually shortlisting the ready mix guys, the plywood. Like, I mean, how was that managed, and were people actually paid for the mock-ups and going through the different phases?
They were, once we got to the mock-up 2,
right,
for supply of the concrete, and that, yes. The shop drawings and that for the formwork guys, they supplied, it was part of the pre-qualification stuff that we had to do. The formwork, we got samples, Silvio, just for the first bit, so it wasn't a big deal to do that. So we did that part. But it was always impressed upon the proponents that we were going through this selective process where you would be, we had shortlisted down to the 3 or 4 that we had for each of the things, and then there would be a technical assessment. That part, yeah, for the where there was a large amount of material or something, they were paid, but if it was a small, like for the panels, that was left up to the ingenuity of the individual proponents.
Thanks. Thank you. I think David has a question. David Calusio.
Yeah, there were a number of questions were answered as you went along, but I had a few. I'm curious about the titanium dioxide. How long does it last? And also just about questions about the color stability over time of the white concrete, and a few others. One is, the tremie pipe, is it left in the wall after
Yes.
you pour?
Yes.
Okay.
Yes. So we went through that with the engineer, and I said to him, I said, we can use either PVC or we could use an elephant trunk, or we use basically a metal conduit. But he didn't have an issue with leaving them in, and that's essentially the best way to do it. Yeah.
And the other two questions I have were just about this process that you've developed. Have you incorporated it into any other projects? And also, what is the status of the building today? How is construction progressing?
Well, as far as incorporating, this is probably one of the more enhanced processes that we've gone through. We did go through similar, and we were working in. I worked in Bogota again for a Richard Rogers building. It was Atrial, and that we went through a similar type thing, a design, a pre-qualification, both technical and commercial. Sorry, and your second question?
Well, just the first question was the titanium dioxide. How does it last and whatnot, color stability?
Yeah, it's something that, from what my research that I've done, it's not something that's it's not like a paint. It's an element, and so it essentially is going to last for a significant amount of time. And so this is all part of the concrete mix that you put in. So it's not a paint. It doesn't wear away. So, and there are a number of buildings, a lot of them in Europe, a lot of them, Alberg Cement, for example, has a lot of projects, and also in Italy that we were looking at, that have been around for 10, 15, 20 years, and I haven't heard of any issues with those either. So I think
and then the final question was the status of the building today. Where are you in construction?
Okay. Well, now here's the issue here. This is what happened is we ran into something called COVID-19. And the Cine Columbia is more or less like Cineplex Odeon. They're a large group in Colombia. They had 50 of these theater complexes that are part of a high-end mall, and all of the families would go to the theaters on the weekends and whatever. And it was a very, very prolific type business. It's because of COVID, everything is stalled. We are now moving up, though. It's a top-down construction, so essentially they are going to complete to the ground level, and that should be done in sometime this early summer. Afterwards, hopefully, if we get a vaccine or whatever, then they will look at the second stage. I don't know if you can add anything more on that, Ryan, or not, but that's sort of my knowledge to date.
Yeah, I was about to say the same thing, that we're on track to finish the foundations and the basement work, I think, by May. So we're still, they're still plodding along, but we haven't been authorized to proceed with any of the shop drawings or submittal process for the above grade floors. So I think, everyone's optimistic that, sometime in late spring, early summer, we'll get back on schedule and start moving along.
Thanks, David. Hassan, you have a question?
Yes, thank you, Silvio, and thank you, Lloyd. That was very impressive and very informative presentation. Well, one thing one takes away is that it's easier to specify than it is to build, obviously. And the question is that we do have sometimes issues where we would put it in our specifications. This is what we would like to see, and if they can't produce it, it's that they can't. It's not that they don't want to produce it if they don't have the know-how. So if there are kind of recommendations on what needs to be said additionally in specifying. And I'm going to be a little bit greedy and ask you a very specific question to get pre-advice. In one situation, we had an SCC concrete, which was in steel form, and we had these kind of vein-like imprints that you see on the face of the concrete, and they could not figure out why it's happening and how to prevent it. So it's not like bubbles, and it's not like honeycombing. It was just like veins that are vertically upward.
Okay. So on that question, that sounds like what you have to do is there's I'm pretty heavy duty into this stuff, but that's a rheology of your concrete, and you're trying to balance a number of attributes. One is the flowability, the ability to go from one point to the next. The two is the ability to hold itself together, to not segregate, and the third is the ability to be able to fill it as fast as you want. So you have to control your yield, your viscosity, and the blend of your materials in order to be able to do this properly. If in fact you have, so there's a number of things that you can measure the properties of the concrete, and one is by just a slump flow and a what's called T50. That's the time it takes to spread to that 50 centimeters. The faster it spreads, the less viscous it is. And so you try to optimize to a number that you have through experience on what is the optimum for being able to spread, fill the forms, and give yourself the property you're looking for. And there's a number of measures that you can do. I would suggest, I probably can't say it all right now on this discussion, but if you look at ACI 237, which is the ACI standard for self-consolidating concrete, it's a very good document that gives you a lot of insight as to all the particulars that you would need to do to measure it. As far as the vein type thing, that sounds to me like you've got a little bit of segregation in your mix and you're getting some bleed channels. What do you think, Heman?
Yeah, they have a name. The name is sand channels, sand path, and this is related with the segregation resistance. So and it's related with, like you say, with the viscosity. So it is very important, the viscosity and the stability of an SCC. But it's
so it was too viscous, and that not viscous enough that would allow it to bleed.
So Hassan, that's your free advice. But you've got Lloyd's address, and Herman's in Colombia, and from now on, you can call them. I'm sure they'd be happy to oblige you for a fee. just kidding.
Yeah, thank you.
I'm gonna.
Lloyd, and thank you for
I'm good. I'm going to move on. Ilana, did you have any? I'm just going to take one more call because we're getting very close to the end. Ilana,
Okay,
did you have?
Thierry has the following question. Yes. Did sunlight exposure at form stripping time also have an influence on color consistency?
Yes, it does. It does. And form stripping time is probably, now I'm gonna temper it a little bit. One of the neat things about the white concrete is because it's so white, it actually doesn't have a dark hue. Whereas if you're with gray concrete, typically you strip it. As soon as you strip it, and if you leave it on the forms for a long time, you get a darkish color on the surface of the concrete. It evaporates over time sometimes and gives you blends a bit, but if you leave the formwork on too long, it will create a dark color. And different than if you, for instance, one you've got on for 3 weeks and another you got on for 2 days. The one for 3 weeks is going to be darker. And Sylvia, you can reflect to that too. I'm sure. Remember on the Sky Dome on I think it was the east one of the ramps. How it looked like it was a checkerboard type thing. Everyone's wondering what was going on. And that was
but that was in the 80s. We were learning back then.
Exactly. But so it does affect for sure. But the nice thing about the white is, I didn't find that as much. I was expecting to see that in some of these situations, but that's the benefit you get with a real white concrete.
Thank you. I'm just going to try to wrap this up. I think this has been a fantastic presentation on Gucci white concrete. I never seen anything like it, and I mean the whole process has been really interesting. And I think, Lloyd, you said something to me the other day that the spec for the concrete was something like 45 pages.
Yeah.
Hopefully it gets published sometime, because I think part of the problem that we as architects and in the industry have is having good specifications to put out there. Sometimes they get used, sometimes they don't, sometimes they get abused more than anything else in the industry. But having good information and how to go out there and get the kind of quality work. One of the things that you helped us out with on the new Toronto courthouse is the meter that you showed, and finally we've got a meter, so we have our checking with a meter what the color of the concrete is, so that we know a little bit better what we're actually looking at. But it's important to really try to understand what it is that we're looking at, because concrete is one of those materials that's really hard to get a handle on. Most of the other materials are a lot easier, but this is a really difficult one. So I'm really hoping, Lloyd, that the research and what you've done at some point in time will be put into the public arena, so that we as architects and engineers can use some of the information that you have.
Well,
so, thank you.
On that, Silvio, I think I mentioned to you, and I know to Ryan too, but we're working at CSA. I'm on the committee 23-1, and in chapter 8, there's a section on architectural concrete. So I'm going to be putting a bunch of different attributes into the present one, because it's sadly lacking. It needs to be beefed up, and I know Ryan's offered to help out with some of this stuff too. So I think we're going to be doing that, and I've got to get something out by the end of the month, at least a draft start on this. So we will be trying to build some of these things that we put from what we're at here too. Yeah.
That's great. And thank you for the presentation. Ryan in New York, thank you, and all the best on the project. It's a fantastic project, and post-COVID, I'm sure that it'll move forward, and it'll garnish a number of awards. So congratulations to you and your firm. And Amanda's been in Colombia. You guys have a fantastic building in Bogota, and all the best. It must be really exciting working on such a great project in Bogota. So thank you to the three of you for being part of this. And for everyone else, thank you for joining us, and look forward to seeing you next month on the NORR Ed. And if you want to watch some movies at the end of this month and into December, please log into the Italian Contemporary Film Festival. And for myself, thanks for joining us for NORR Ed.